I'm gonna write this function first. Is even. Is even. Is a number even? So this is gonna be a function from number to Boolean. The logic, I don't really care. When I program, I care about this here, and what goes here, basically, I want somebody else to do that. What matters is that it's a function from number to Boolean, okay? Similarly, I'm gonna write is odd. Is odd is also a function from number to Boolean. Since I already have the function is even, I can write this function like this, right? Like the not is not even, right? So if it's not even, it must be odd. And now let me write another one, a function from string to Boolean. What I want you to think about is that we have three functions from some type to Boolean. Now let's reinvent the Array.filter function. When you have something like 1, 2, 3, and you filter this with is even, and the result is gonna be this, right? Okay, so this function, as you know, is gonna receive a couple of arguments, a function and an array. 2 arguments for Array.filter, and now let's implement it using reduce. Reduce is like the mother of all natural operations on the array. So you can write reverse, map, slice, so on and so forth, many natural array functions using reduce. How do we use reduce? We pass it a callback that takes 2 arguments. One is the result so far, and an item from the array we are iterating. That's what reduce does, right? It iterates the array and keeps track here of what we return each time. It also receives the base, well, it's called initial value here, but yeah, I guess initial value. So if this array is empty, then this is what reduce is going to return. Okay, so now what am I gonna do here? I'm gonna return something depending on what this function tells me, right? Because I'm gonna use this function to filter the contents. So let me apply this function to this element of the array. If the function is true, I'm gonna concatenate to the results so far. I'm gonna concatenate, this element. Because in a sense, it passed the test, right? So we keep the element in the results. Otherwise, we throw away the n, and so we just return the results. So now that we have Array.filter, let's do a couple of examples. Let's say we have a bunch of numbers, 1, 2, 3, 4, 5. We can use Array.filter now like this. Let's say we want the evens. And how do we get them? By filtering with our function. Well, we pass is even and the bunch of nums. I'm gonna call it just all nums, shorter, okay? So cool, we have this, and the result is the array of evens. Let's see, alert. So 2, 4, 6, okay, cool. So this function does not need to be specific to number, did not need to know that the function, that this is a number, okay? So if I try to do this, array of strings, and I have a bunch of strings, A, B, C, and let's say that this is empty for the example. And so I want to filter by is empty. No, this is not what I want. If it's not empty, It's not empty. Okay, this should be the right name for this function. I can't use this logic that should work, but I can't use it because I'm now using strings, and this function needs numbers because of the type. And so generics to the rescue here, because with generics I can stop talking about a specific type and instead use type parameters. Okay, how do we use type parameters in order to make this function generic in its type? Well, first I introduce the type parameters I want to use. I'm going to use a instead of number, a instead of number, and a instead of number here. Okay, so now, oh, and I'm going to use a instead of number here and a instead of number here, right? I did not change the logic and still compiles. It's all good. And so this is why you use generics. Because you have this logic and you do not want to make it unnecessarily specific to any particular type. Okay, good. So now let's talk about why you shouldn't use any. Because some people may be asking, why not use any instead of generics? Now, the number one reason not to do that is that I will find you and I will kill you. Now, number one reason, okay, so any makes you lose type information. Let's just copy paste this and create the evil version of this. Array filter evil, or evil array filter. Well, does that mean that the array itself is evil? No, that's array filter evil. But now this sounds like we are filtering the evil out of the array. Anyway, just this is the one that's wrong, okay? So instead of generics, we're gonna use any. So we go here, we get rid of the type parameter, and then we change this to any, any, and here, any, any, here, any, okay, any, again, okay, so it still works, right? And we can, we can still use this one now, and everything seems to work, except now this function returns an array of any. I can say that, okay, so, this is an array of Boolean, and nobody complains. I can even go like movie, ID, title, duration. So we got a bunch of movies here, but no, this is not an array of movies. Events is still an array of numbers, but this is now type checking because the output of this function can be assigned to anything, basically. And so you're essentially eliminating, destroying the type information. And that's really bad because this might compile now, but then of course at runtime you might start getting all kinds of errors. So don't use any when you want to do something like this. Try to make it work as hard as you can with generics. Generics preserves the type information. And so if I use the good generic array filter, now the type checker is going to tell me, hey, this is not an array of movies. This is an array of numbers. You cannot assign an array of numbers, which is what you got, to the type movie array, right? Why? Well, because a number is not a movie. Okay, so the bottom line is that we use generics when we want to write a function and we don't want to make it specific to a particular type. And we also don't want to lose type information, right? And so we use type parameters. Okay, cool. What else? No, I'm gonna leave it here. So yeah, generics, good. Any, bad. Okay, so if you learned anything from this video, is that generics, good. Any, bad. Generics, good. Any, bad. Generics, good. Any, bad. Generics, good. Any, bad.